September 15th, 1944, Hürtgen Forest, Germany. The concrete bunker, designated Pillbox 347 by Allied intelligence, sat silent among the ancient pines. Its firing slits watched the muddy approach like dead eyes. Inside, 6 Wehrmacht soldiers of the 275th Infantry Division huddled in the darkness waiting. They had ammunition, food for 3 days, and confidence. These fortifications had been built to last 1,000 years, walls 3 ft thick, reinforced with steel rebar, impervious to anything short of a direct artillery hit. Obergefreiter Klaus Brenner, 23 years old, a veteran of the Eastern Front, checked his MG-42 machine gun one more time. The Americans would come, as they always did. They would try grenades that would bounce harmlessly off concrete. They would fire their rifles uselessly at firing slits. Eventually, they would call for tanks or artillery, and by then, the defenders would have inflicted enough casualties to justify their position. That was the doctrine, the mathematics of defensive warfare. What Brenner and his comrades didn't know was that approaching through the forest, carried by 2 soldiers of the 1st Infantry Division's 18th Regiment, was a weapon that would transform their concrete fortress into a crematorium in less than 30 seconds. The M2 flamethrower, 68 Elb of pressure tanks, fuel and ignition system, represented a fundamental shift in battlefield technology. It didn't defeat fortifications through kinetic force or explosive power. It bypassed the concept of fortification entirely, turning defensive strength into a death trap. This is the story of how fire became the most psychologically devastating weapon on the Western Front, how German confidence in concrete defences turned to absolute terror, and how American combat engineers discovered that sometimes the most effective way through a bunker wasn't around it or over it, but into it. The development of the American flamethrower program began in earnest in 1942, years after other nations had fielded such weapons. The German army had used flamethrowers in World War I with devastating effect. The Soviets had employed them extensively. The Japanese terrorized Chinese defenders with portable flame weapons throughout the 1930s. America, with its cultural aversion to weapons deemed inhumane, had resisted. That changed with Guadalcanal. Marine units attempting to clear Japanese bunkers on the Pacific Islands discovered that conventional weapons were nearly useless against well-constructed fortifications. A Japanese pillbox built from coconut logs and coral could absorb dozens of grenades and thousands of rifle rounds without effect. The defenders inside, safe behind firing slits, could pin down entire companies indefinitely. The Marines improvised flame weapons using portable fuel tanks and improvised igniters. The results were immediate and horrifying. Bunkers that had resisted assault for days were neutralized in minutes, but these improvised weapons were dangerous to operators and unreliable. The Chemical Warfare Service, responsible for developing specialized weapons, was ordered to create a portable, effective, and safer flamethrower for American forces. The result was the M1 flamethrower, fielded in 1943. But combat experience revealed critical flaws. The ignition system was unreliable, the range was insufficient, the fuel mixture burned too quickly, exhausting the weapon in seconds. By late 1943, the M2 model addressed these problems with redesigned pressure regulators, improved fuel formulation, and a more reliable electric ignition system. The M2 flamethrower that would see widespread use in Europe was a sophisticated piece of engineering. 2 cylindrical tanks mounted on a backpack frame held the fuel and propellant. The lower tank contained 4 gallons of thickened fuel, a mixture of gasoline, benzene, and a secret thickening agent that would later be refined into napalm. The upper tank held compressed nitrogen at 360 pounds per square inch, providing the pressure to expel fuel through the gun. The gun itself was a masterpiece of compact design. A trigger valve controlled fuel flow. An electric spark igniter powered by a small battery and magneto system created the initial flame at the nozzle. Once ignited, the burning fuel stream became self-sustaining, a jet of fire reaching 130 ft under optimal conditions. The effective range was typically 65 to 100 FD, depending on wind and fuel viscosity. At maximum discharge rate, an M2 flamethrower could exhaust its fuel in 10 seconds. This limitation forced operators to use short bursts, typically 1 to 2 seconds each, making the weapon's 4-gallon capacity last for 10 to 15 bursts. Each burst consumed approximately half a pint of fuel, transforming it into a stream of fire hot enough to melt steel. The fuel mixture was crucial to effectiveness. Early experiments with straight gasoline produced impressive flame but limited range and poor adherence to targets. The liquid dispersed in the air, burning quickly but superficially. The addition of thickening agents, initially soap-based compounds, later more sophisticated polymers, transformed the fuel into a viscous gel that maintained coherence through the air, stuck to whatever it hit, and burned longer and hotter than liquid fuel. The psychological effect of this adhering flame was immediate and profound. Conventional explosives created momentary terror, followed by relief among survivors. Flamethrowers created sustained, inescapable horror. The fuel clung to uniforms, equipment, and exposed skin, burning intensely for 30 to 60 seconds. Water didn't extinguish it effectively. Rolling on the ground spread the flames. The only escape was to strip away burning clothing immediately, something nearly impossible in combat conditions. Training flamethrower operators was both physically and psychologically demanding. The weapon weighed 68 decibel fully loaded, requiring significant strength to carry and operate. The operator needed to approach within 100 ftf of enemy positions, often much closer, while carrying what amounted to 2 bombs of volatile fuel on his back. Rifle fire could ignite the fuel tanks, transforming the operator into a human torch. The training program, conducted at specialized facilities in the United States, began with physical conditioning. Operators had to prove they could carry the full weapon load for extended periods over rough terrain. They practiced movement with the heavy backpack, learning to maintain balance while negotiating obstacles. Next came familiarization with the weapon's operation. Loading the fuel tanks, pressurizing the nitrogen cylinder, testing the ignition system, understanding the trigger mechanism. Trainees learned to recognize when fuel pressure was dropping, when ignition systems were failing, when fuel flow was obstructed. Live fire training began with stationary targets. Operators learned to control burst length, to walk fire into targets, to compensate for wind. They practiced engaging multiple targets in sequence, maximizing the limited fuel supply. Advanced training included movement under fire, coordination with supporting infantry, and specialized techniques for bunker assault. The psychological preparation was equally important. Instructors emphasized that flamethrower operators had extraordinarily high casualty rates. The weapon marked its operator as a priority target. German and Japanese forces trained their soldiers to recognize flamethrower operators by their distinctive backpack and to concentrate fire on them immediately. Operators needed to accept that survival depended on speed, surprise, and aggressive action. The first major use of American flamethrowers in Europe came during the Normandy hedgerow, fighting in June and July 1944. The Norman bocage, ancient agricultural land divided by thick hedgerows on raised earthen banks, created thousands of natural fortifications. German forces had reinforced these positions with machine gun nests, concrete bunkers, and interconnected fighting positions that turned every field into a potential killing ground. Sergeant Richard Harrison of the 2nd Infantry Division's combat engineers was among the first flamethrower operators committed to combat in the hedgerows. His after-action report, filed on July 2, 1944, described the weapon's effectiveness with clinical precision. Position designated target Baker, concrete reinforced machine gun nest built into hedgerow embankment. Conventional assault resulted in 3 casualties with no damage to position. Approached from covered position to within 50 ft, fired 3-second bursts directly into firing slit. Immediate secondary explosions observed, likely ammunition cooking off. Screaming heard from interior. No further resistance from position. Estimated time from first burst to complete neutralization, 15 seconds. What Harrison's report didn't convey was the psychological shock experienced by German defenders. Wehrmacht soldiers had faced artillery, mortars, grenades, and small arms fire. Those weapons killed, but they killed cleanly, instantaneously in many cases. The flamethrower was different. The flame entered the bunker through firing slits designed for outgoing fire. The burning fuel filled the confined space, consuming oxygen and creating toxic gases. Defenders faced a choice: burn alive in the bunker or flee into the open where American riflemen waited. Most chose to burn. The temperature inside a bunker under flamethrower attack reached 2000 F within seconds. At that temperature, exposed skin blistered instantly. Uniforms ignited. Ammunition and grenades cooked off. The air itself became unbreathable, superheated gases searing lungs with each breath. Death came from burning, from suffocation, from toxic gas inhalation, or from ammunition explosions. It was never quick and rarely clean. German forces in Normandy, initially confident in their defensive positions, began reporting a new weapon in American hands. Intelligence summaries from early July 1944, captured after the war, revealed growing concern. Enemy employing flame projector weapons against fortified positions, conventional defensive measures ineffective, psychological impact on troops severe, casualties among defenders approaching 100% when weapons successfully employed, recommend immediate development of countermeasures. But effective countermeasures were nearly impossible. The obvious solution was to kill the flamethrower operator before he reached effective range. German soldiers were instructed to recognize the distinctive backpack and target flamethrower operators preferentially. This made operating the weapon extraordinarily dangerous, but didn't reduce its effectiveness. American tactics evolved to protect flamethrower operators. Infantry squads would suppress enemy positions with rifle and machine gun fire while the operator approached. Smoke grenades obscured the operator's advance. Supporting armor provided mobile cover. The flamethrower operator rarely worked alone. A typical bunker assault team included the operator, an assistant carrying extra fuel, and 4 to 6 riflemen providing cover and security. The procedure was rehearsed until it became mechanical. The team would approach the target under covering fire. The operator would move to within effective range, typically 50 to 75 fed. He would aim for the firing slit or any opening in the fortification. A 2 to 3 second burst would send a stream of burning fuel into the interior. Then the team would withdraw while riflemen covered the bunker exits, ready to engage any defenders attempting to escape. In the Hurtgen forest, these tactics were refined to deadly efficiency. The forest fighting, beginning in September 1944, presented unique challenges. The Germans had fortified the area extensively, building hundreds of bunkers, pillboxes, and reinforced positions among the trees. The dense forest canopy limited artillery, observation, and air support. Traditional infantry assaults resulted in horrific casualties for minimal gains. Flamethrowers became the primary tool for breaking the defensive lines. Sergeant James Thompson of the 4th Infantry Division described the forest fighting in a letter written in October 1944. The pillboxes are everywhere. You can walk past one and never see it until it opens fire. We lost an entire platoon in an hour trying to take a single position with grenades and satchel charges. Then the engineers came up with their flame tanks. It's like nothing I've ever seen. The flame shoots out and just disappears into the firing slit. Then you hear screaming, explosions, more screaming. Sometimes they run out, on fire, begging in German. We have to shoot them. It's mercy at that point. The guys with the flamethrowers don't talk much. They know every German in the forest is trying to kill them specifically, but they keep going forward. The psychological toll on flamethrower operators was severe. Unlike riflemen who killed at a distance, flamethrower operators witnessed the immediate and terrible effects of their weapons. They heard the screaming. They smelled burning flesh. They saw defenders, often teenagers or old men by late 1944, stumbling from bunkers engulfed in flames. Some operators developed what would later be recognized as post-traumatic stress disorder. Others became coldly mechanical, viewing their role as necessary but detaching emotionally from the consequences. A few, concerning to commanders, seemed to enjoy the power of the weapon. One such operator, whose name was redacted from military records, was removed from duty after laughing while burning a bunker in November 1944. Psychological evaluation determined he had become desensitized to violence and posed a risk to his own unit. German defenders, witnessing the fate of their comrades, developed a pathological fear of flamethrowers. Captured Wehrmacht soldiers from the Hurtgen fighting repeatedly mentioned the flame weapons in interrogations. One prisoner, a 19-year-old from Stuttgart captured in October 1944, described the psychological impact. We called them Flammenwerfer, flamethrowers, but that doesn't capture what they are. They're death machines. You can't fight them. You can hide in concrete and steal, and the flame finds you anyway. I saw a bunker attacked. The flame went in through a slit barely 6 inches wide. The screaming lasted almost a minute. Then ammunition started exploding. One man ran out. He was on fire from head to foot. He fell after 10 steps and burned like a candle. After that, When we heard Americans had flame weapons nearby, men would volunteer for any other duty. Anything to not be in a bunker when those weapons came. Some deserted rather than face them. The fear was worse than artillery, worse than tanks. Those kill you quick, if they kill you at all. The flame is different. The technical evolution of American flamethrower tactics continued throughout late 1944. Combat engineers discovered that the weapon's effectiveness could be enhanced by understanding bunker design and airflow. A burst directed at a firing slit would be drawn into the bunker by air currents, following the path of least resistance through the interior. If multiple openings existed, the flame would flow through the structure like water, seeking exits. This led to the development of coordinated multiple operator assaults. 2 or 3 flamethrower operators would attack a bunker simultaneously from different angles, directing flame into multiple openings. The burning fuel would fill the entire interior space, making survival impossible. These coordinated attacks reduced the time required to neutralize positions from minutes to seconds. The Battle of Aachen in October 1944 saw flamethrowers employed in urban warfare for the first time in Europe. The ancient German city, heavily fortified with bunkers, pillboxes, and fortified buildings, required weeks of brutal fighting to capture. Flamethrowers proved decisive in clearing fortified structures. Corporal Michael Chen of the 1st Infantry Division participated in the street fighting. His account described the urban flamethrower tactics. The buildings were fortified, every window a firing position, every basement a bunker. We'd try grenades, bazookas, everything. The Germans would just wait us out. Then we started using flame. One burst through a ground floor window, and the whole building would clear out. Sometimes they'd surrender. Sometimes they'd run and get shot. Sometimes they didn't come out at all. We found bodies later, burned so badly you couldn't tell they'd been human. The flame didn't just burn, it consumed oxygen in enclosed spaces. We found defenders who weren't burned but had suffocated when the fire used up all the air. One basement bunker had 7 men dead, not a mark on them except their faces were blue. They'd breathed toxic fumes and died in seconds. The urban environment presented unique challenges for flamethrower operations. Buildings provided cover for approach, but also created confined spaces where fuel vapors could accumulate before ignition, risking operators. Multi-story structures required careful assessment of where defenders might be positioned. Basements were particularly dangerous as burning fuel would flow downward, seeking the lowest point, creating infernos in underground spaces. American combat engineers developed specialized urban tactics. They would identify all visible openings in a target building, windows, doors, ventilation shafts, holes from previous artillery damage. Then they would position flamethrower operators to cover multiple openings simultaneously. The attack would begin with a demonstration burst. Flame shot into an upper floor window where defenders could see it but weren't positioned. This gave occupants a chance to surrender. If they didn't, the real attack commenced. Operators would fire into ground, floor openings, filling the building from bottom to top. The rising heat and smoke would drive defenders upward, where additional operators waited to engage upper floor positions. Buildings that refused to surrender would burn. The fuel would ignite wooden interior structures, furniture, support beams. Within minutes, the entire building would be ablaze. Defenders faced the choice of burning alive or attempting escape through windows and doors covered by American riflemen. The psychological pressure was unbearable. German military leadership attempted to develop countermeasures throughout the fall of 1944. Tactical bulletins distributed to frontline units advised on flame weapon defense. Bunkers were to be designed with multiple exits and improved ventilation to prevent flame and gas accumulation. Firing slits were to be narrowed and equipped with metal baffles to deflect flame. Personnel were instructed to drench clothing with water before combat, supposedly to provide brief protection against flame. None of these measures proved effective in practice. Improved ventilation meant flame could enter more easily. Multiple exits provided more avenues for attack. Wet clothing offered no meaningful protection against fuel burning at 2000 DGGF. Metal baffles could deflect some flame but couldn't prevent fuel from entering and pooling on the bunker floor, where it would burn just as effectively. The tactical bulletin served primarily to remind soldiers that headquarters had no solution to the flamethrower problem. Some German units attempted more desperate measures. In the Siegfried Line fortifications, some bunkers installed water spray systems designed to flood firing slits when attacked. The theory was that water would extinguish flame or prevent fuel entry. In practice, the pressurized fuel stream simply pushed through the water spray. Worse, water on the floor created steam when flame entered, scalding defenders just as effectively as direct flame. Other bunkers tried installing steel blast doors over firing slits that could be closed when flame weapons approached. This worked once. American forces simply waited for the doors to open for German defensive fire, then hit the position with flame. After closing the doors once to avoid flame, defenders had to choose between keeping the doors closed and being unable to fight, or opening them and being burned. Most chose to surrender rather than face this impossible choice. By December 1944, during the Battle of the Bulge, German forces demonstrated their respect for American flamethrowers through their actions. Captured orders from the 12th SS Panzer Division specified that flamethrower operators were to be killed immediately if captured and not treated as prisoners of war. This violation of the Geneva Conventions reflected the psychological impact these weapons had achieved. American forces responded by ensuring flamethrower operators fought in mixed units, where their role wasn't immediately obvious. The bulky fuel tanks were sometimes carried by assistants until the moment of use. Operators wore standard infantry uniforms without identifying marks. These measures reduced but never eliminated the extraordinary danger faced by flamethrower operators. The casualty rates told the story. In the European theatre between June 1944 and May 1945, flamethrower operators suffered casualties at 3 times the rate of standard infantry. Approximately 40% of trained operators became casualties compared to 13% for regular infantry. Yet volunteers continued to come forward. Some were motivated by extra pay. Operators received hazardous duty compensation. Others sought the psychological advantage of carrying the most feared weapon on the battlefield. Many simply recognized that flamethrowers saved lives overall, by reducing the time and casualties required to neutralize fortifications. Private First Class Robert Wilson volunteered for flamethrower training in January 1945 after watching conventional assaults on German bunkers cost his unit dozens of casualties. His reasoning, documented in a letter to his parents, was pragmatic. I'd rather carry the flamethrower and have every German in Europe trying to kill me than watch my buddies die trying to take pillboxes with grenades. With flame, one man can clear a bunker in seconds. Without it, a whole squad can die trying. The Germans are terrified of it. They surrender when they see it coming. That saves American lives. If I get killed doing this, at least I'll have saved some of my friends. Wilson survived the war with a Purple Heart from shrapnel wounds suffered during a bunker assault in March 1945. He was one of the lucky ones. The technical development of American flame weapons continued even as the war progressed. The M2A1 variant, introduced in early 1945, featured improved fuel capacity, 5 gallons instead of 4, and a refined nozzle design that increased effective range to 140 atioffs. The fuel mixture was enhanced with early napalm compounds, aluminum naphthenate and aluminum palmitate dissolved in gasoline, creating a gel that burned hotter and longer than previous mixtures. The new napalm fuel introduced in early 1945 represented a quantum leap in effectiveness. The gel adhered to virtually any surface, vertical walls, steel armor, even wet concrete. It burned at temperatures exceeding 2500 Joule F, hot enough to weaken structural steel. Most terrifyingly, it was nearly impossible to extinguish. Water spread it rather than extinguishing it. Smothering with dirt or sand was only partially effective. The fuel continued burning until chemically exhausted, typically 60 to 90 seconds. The chemistry behind napalm was deceptively simple. Aluminum soaps, derived from naphthenic and palmitic acids, dissolved in gasoline formed long polymer chains that transformed the liquid into a gel. This gel maintained liquid properties under pressure, allowing it to flow through the flamethrower gun but immediately returned to gel form when expelled, maintaining coherence in flight. Upon impact, the gel spread across surfaces and adhered through a combination of viscosity and slight adhesive properties. The burning gel generated sufficient heat to cause secondary fires in combustible materials, meaning that a single burst could ignite everything flammable in a room, creating a self-sustaining conflagration that persisted long after the original fuel was exhausted. German soldiers encountering the new napalm mixture faced an enemy that seemed beyond human capacity to combat. A short burst, 2 seconds, would deliver approximately 1 quart of fuel. That quart would splash across a 6FT area and burn for over a minute. Anything organic, wood, cloth, human tissue, would be consumed. Metal would be scorched and deformed. Concrete would crack from thermal shock. The testimony of German survivors from early 1945 operations revealed complete psychological collapse when facing napalm-based flamethrowers. One Fallschirmjäger, paratroop, sergeant captured near the Remagen bridgehead in March 1945 described the experience. The Americans attacked our position with the new flame weapons. The fuel, it stuck to everything. I saw it splash onto a man's uniform and he couldn't get it off. He rolled. He tried to wipe it away, it just spread. He burned for what seemed like forever, screaming. The smell, God, the smell. After that, when we heard Americans were bringing up flame weapons, men simply abandoned positions. Officers would threaten to shoot deserters. Men said they'd rather be shot quickly than burn. I surrendered rather than face those flames again. I'm not ashamed. No human should have to face that. The industrial scale of American flamethrower production matched other aspects of US war material output. By early 1945, production reached 2,000 M2 flamethrowers per month. Fuel production exceeded 500,000 gallons monthly, enough to equip hundreds of specialized units. Training facilities graduated 500 qualified operators monthly, replacing casualties and expanding capability. The logistics of flamethrower operations were substantial. Each flamethrower required 4 to 5 gallons of specialized fuel, which had to be transported from rear area depots. Refueling in combat conditions was dangerous, requiring 10 to 15 minutes of vulnerable time while operators connected fuel lines and pressurized nitrogen cylinders. Maintenance was constant. The seals and valves required regular inspection. The ignition system needed frequent testing. The tanks had to be checked for leaks or damage. A single failure could mean death for the operator. Fuel leaks, even small ones, created vapor clouds that could ignite from muzzle flash or tracer rounds. Ignition system failures left operators with a useless weapon at point-blank range with enemy positions. Pressure system failures could cause catastrophic tank ruptures. The maintenance crews who kept flamethrowers operational were unsung heroes of the weapon system. These specialists, usually assigned to combat engineer companies, performed dangerous work under combat conditions. They handled volatile fuel, worked with high-pressure systems, and tested ignition mechanisms that could potentially ignite fuel vapors. The casualty rate among flamethrower maintenance personnel, while lower than operators, still exceeded that of standard support troops. German intelligence assessments from early 1945, captured after the war, revealed complete acknowledgement of the weapon's dominance. A report prepared for the Wehrmacht High Command in February 1945 concluded that conventional defensive tactics were obsolete in the face of American flamethrowers. The American flame projector has fundamentally altered defensive warfare. Fortifications, previously the basis of defensive operations, have become death traps. Troops will not man positions they know will be attacked with flame weapons. Morale collapse is immediate when these weapons appear. Recommendation: acknowledge that static defense against American forces equipped with flame weapons is no longer viable. Emphasis must shift to mobile defense and immediate counterattack before flame weapon teams can be brought forward. But mobile defense required fuel for vehicles and tanks. Immediate counterattack required experienced troops and ammunition. By early 1945, Germany had none of these in sufficient quantity. The defensive lines were manned by undertrained replacements, teenagers and old men, who broke and ran at the first sight of flamethrowers. The final months of the war in Europe saw flamethrowers employed in the crossing of the Rhine and the reduction of the Ruhr pocket. German forces, compressed into shrinking defensive perimeters, had built extensive fortifications. American forces, by now experienced in flame warfare, systematically burned them out. The crossing of the Rhine in March 1945 involved some of the most intensive flamethrower operations of the war. German bunkers on the eastern bank, designed to dominate the river crossings, were targeted by specialized flame weapon teams transported in assault boats. These teams would land, advance under covering fire, and burn out bunkers from the rear, the side German engineers had assumed was safe. Lieutenant Thomas Bradley led one such team across the Rhine near Wessel on March 23, 1945. His account described the operation. "We crossed at night in assault boats, 8 men, 2 with flamethrowers, the rest with rifles and bars. The bunker we were targeting had been stopping attempts to expand the bridgehead for 2 days. It was built into the riverbank, concrete walls, steel door, firing slits covering the approach from the water. The Germans never thought anyone would come at it from behind. We landed 200 YD downstream, worked our way up the bank. The bunker rear had a ventilation shaft and an emergency exit, both barely visible. We set up on the exit, ready to shoot anyone coming out. Then both flamethrower operators opened up on the ventilation shaft simultaneously. The flame just poured in. After 10 seconds, we heard screaming. Ammunition started cooking off inside, sounding like firecrackers. The steel door blew open and 3 men stumbled out on fire blind, screaming in German. We shot them. It was mercy. They were going to die anyway. The bunker burned for 20 minutes. We could feel the heat from 50 FT away. When we finally looked inside, there were 9 more bodies. Some burned, some looked like they'd suffocated. The walls were scorched black. Ammunition was scattered everywhere, cooked off by the heat. The whole thing took less than 5 minutes from first burst to securing the position. The Rhine crossing demonstrated the evolution of American combined arms tactics with flamethrowers as a central element. Artillery would suppress German positions to prevent them from firing on the boats. Smoke shells would obscure the crossing. Assault boats would land specialized teams behind German lines. These teams, protected by riflemen and supported by radio communication with artillery, would systematically neutralize bunkers from the rear using flame weapons. The Germans, having designed their fortifications to resist frontal assault, found their strongest defences worthless against attack from behind. The Ruhr pocket reduction in April 1945 involved clearing hundreds of fortified positions as German forces made their last stand in the industrial heartland. Flamethrowers were employed so extensively that some units exhausted their fuel supplies and had to wait for resupply before continuing operations. The statistics from the Ruhr fighting demonstrated the weapon's effectiveness. American forces estimated that conventional assault methods required 30 to 60 minutes per fortified position, with average casualties of 3 to 5 men. Flamethrower assaults reduced time to 5 to 10 minutes with average casualties of less than 1 man. The mathematics were undeniable. Flame weapons saved American lives while guaranteeing German casualties. The Ruhr pocket contained approximately 430,000 German soldiers, many in fortified positions within the industrial cities. American forces using flamethrowers as their primary bunker-busting weapon reduced the pocket in 18 days. Over 300 fortified positions were neutralized with flame weapons. The psychological impact caused mass surrenders. Entire German units, seeing neighboring positions burned out, would surrender rather than wait their turn. By the war's end in May 1945, German military forces had developed an almost superstitious fear of American flamethrowers. Interrogation records from the final weeks showed that mere rumours of flame weapon teams nearby could trigger surrenders and desertions. The psychological dominance was complete. One of the last recorded uses of flamethrowers in Europe occurred on May 5, 1945, near Berchtesgaden. A German SS unit, fanatics who refused to surrender, had fortified a mountain position and declared they would fight to the death. American forces brought up flamethrowers. After a single demonstration burst that set a wooden outbuilding ablaze, the SS unit surrendered en masse. Even the most ideologically committed soldiers chose captivity over facing the flames. The post-war assessment of flamethrower effectiveness was compiled by the US Army's Operations Research Office in 1946. The report concluded that portable flamethrowers were among the most cost-effective weapons of the war. Each flamethrower cost approximately $500 to produce. Each gallon of fuel cost $2. The average flamethrower neutralized 5 to 7 fortified positions before being lost to combat damage or wear. Each neutralized position would have required estimated 50 man-hours and 5 casualties to reduce through conventional means. The return on investment was extraordinary. A $500 weapon and $50 worth of fuel could accomplish what would otherwise cost dozens of lives and days of combat. But the report also acknowledged the psychological cost. Flamethrower operators suffered from post-traumatic stress disorder at rates significantly higher than other combat troops. The intimacy of the killing, the sounds and smells, the knowledge of what the weapon did to human beings, created lasting psychological trauma. The Veterans Administration would treat flamethrower operators for decades after the war, many never fully recovering from what they had witnessed and done. German veterans, interviewed decades after the war, consistently ranked American flamethrowers among the most psychologically devastating weapons they faced. The fear exceeded that inspired by artillery, tanks, or aircraft. The flamethrower was personal, intimate, and absolutely terrifying in a way that standoff weapons were not. Former Wehrmacht Lieutenant Hans Müller, interviewed in 1978, captured the lasting psychological impact. I faced Russian artillery at Stalingrad, British tanks in Normandy, American aircraft everywhere. None of it compared to the fear I felt seeing American soldiers with flamethrowers. The other weapons might kill you, probably would kill you eventually, but they killed you quick. The flame, that was different. You knew what was coming. You'd hear the whoosh of the ignition, see the flame coming at your position, and you knew you had seconds to choose, burn or run into gunfire. I chose to run. Many of us did. I was lucky. I only got shot in the leg. Better than burning. The men who died in the flames, we found them sometimes. The smell never leaves you. Burned flesh, gasoline, melted rubber and plastic. And the sounds, the screaming. In nightmares. 30 years later, I still hear those screams. The American flamethrower didn't just defeat our fortifications, it defeated our will to fight. The development of American flamethrower tactics in Europe demonstrated how a weapon could achieve effects far beyond its direct destructive capability. The actual number of German soldiers killed by flamethrowers was relatively small, estimated at less than 10,000 in the European theatre, but the psychological impact affected hundreds of thousands. German soldiers throughout the theatre knew about the flame weapons. They heard the stories, saw the aftermath, knew what awaited them if they remained in fortified positions. This knowledge changed behaviour. Defensive positions were abandoned more readily. Surrender became more acceptable. The will to continue fighting eroded. The technical specifications of the M2 flamethrower seemed modest compared to other weapons. It weighed less than a bazooka. It cost less than a machine gun. Its range was shorter than a rifle. Yet its battlefield impact exceeded weapons that were larger, more expensive and more powerful. The secret was psychological leverage. The flamethrower exploited fundamental human fears. Fire is primal, dangerous, terrifying in ways that other weapons are not. Bullets kill, but fire consumes. The distinction mattered profoundly to soldiers facing these weapons. The American military had discovered and weaponized this psychological reality. Training emphasized not just the technical operation of the weapon, but its psychological employment. Operators were taught to give defenders a chance to surrender before using flame when tactically feasible. This wasn't mercy, it was psychological warfare. Defenders who witnessed a demonstration burst understood exactly what would happen if they didn't surrender. The choice between certain death by burning and possible survival as prisoners was no choice at all. The surrender rates for positions threatened with flamethrowers exceeded 60%, compared to less than 20% for positions under conventional attack. The weapon's reputation did as much work as the weapon itself. In the final accounting, the American flamethrower succeeded because it attacked the enemy's will rather than just his fortifications. German concrete and steel could resist conventional weapons indefinitely. German soldiers could endure artillery bombardment, tank attacks, and infantry assaults with remarkable resilience. But no amount of fortification or courage could make a man willing to burn alive. The flame found the limit of human endurance and exploited it ruthlessly. The veterans who carried these weapons paid a price for their effectiveness. Many struggled with guilt over what they had done, even understanding it was necessary. The sounds and images haunted them. Some found solace in the knowledge they had saved American lives. Others never found peace. Technical Sergeant William Cooper, a flamethrower operator who served from Normandy to the Elbe, wrote in his memoirs published in 1989, "I killed men with fire. I heard them scream. I smelled them burn. I did this dozens of times. 50 years later, I still wake up some nights hearing those screams. But I also know that every bunker I burned was a bunker that couldn't kill American soldiers. Every German who surrendered because he feared my weapon was a German who didn't shoot at my friends. I carry the burden of what I did so that other men didn't have to. If I could go back, knowing what I know now, I'd do it again. But I'd never wish this burden on another human being." The American flamethrower stands as one of the most effective yet morally complex weapons of World War II. It saved thousands of American lives by breaking German defensive capabilities. It shortened battles and reduced casualties on both sides through its psychological impact. But it did so through a method of killing that remains disturbing even in the context of total war. In September 1944, in Hurtgen Forest, Obergefreiter Klaus Brenner and his 5 comrades huddled in their concrete bunker as American infantry approached. They heard the distinctive sound of small arms fire, the steady fire of an M1 Garand, the faster stutter of a bar. Then a new sound, a mechanical hiss followed by a roar like a blast furnace. Brenner, veteran of the Eastern Front, recognized it instantly. "Flammenwerfer," he whispered. His comrades went silent. They'd heard the stories. Now the stories were 50 ft away and getting closer. Through the firing slit, Brenner could see movement in the trees. American soldiers, advancing in small groups, using the forest for cover. Then he saw it, a soldier carrying the distinctive double-tank backpack, moving deliberately toward their position. Another soldier walked beside him, rifle ready, providing security. The flamethrower operator stopped approximately 60 ft from the bunker and began adjusting something on his weapon. Brenner made a decision that probably saved his life. He shouted in broken English through the firing slit, "We surrender, do not burn, we come out." The American voice that answered was young, probably not yet 20 years old. "Come out with hands up right now, or I start cooking." There was no hesitation in the voice, no room for negotiation. Brenner and his men stumbled out into the daylight, hands raised, expecting to be shot. Instead, they saw an American soldier barely visible behind a weapon that looked like something from hell itself. 2 cylindrical tanks, a gun with a pilot light flickering at the nozzle, and a look of cold readiness on the operator's face. The operator didn't lower the weapon until all 6 Germans were face down on the ground with hands behind their heads. Then he called out, "Position clear, no fire required." Brenner would survive the war as a prisoner. Decades later, he would tell interviewers that the smartest decision of his life was surrendering to the flamethrower operator before the weapon was used. "I saw what happened to positions that didn't surrender," he said in a 1982 interview. "The Americans would demonstrate the flamethrower once, burning something visible. Then they'd give you one chance to come out. If you didn't, they burned you alive." I wasn't dying for Hitler in a concrete box. None of us were by that point. The psychological transformation of German defensive doctrine in the face of flamethrowers represented a complete reversal of tactical thinking. Before the widespread deployment of American flame weapons, German defensive strategy emphasized static fortifications, concrete bunkers, pillboxes, and reinforced positions from which small groups could hold against larger forces indefinitely. After experiencing flame attacks, German tactical manuals shifted emphasis toward mobile defense and immediate counterattack, anything to avoid being trapped in a position that could be burned. This shift, forced by a single weapon system, fundamentally undermined Germany's defensive capabilities in the final year of the war. Without the ability to rely on fortifications, German forces lost their primary force multiplier. Undermanned and undersupplied units that could have held fortified positions for days or weeks were forced into mobile operations they lacked the resources to sustain. The ripple effects of the flamethrower extended far beyond the bunkers it actually burned. The weapon also changed American infantry doctrine in lasting ways. Pre-war US Army tactical manuals emphasized frontal assault and overwhelming firepower as solutions to fortified positions. Combat experience with flamethrowers demonstrated that specialized weapons employed by small teams could achieve what entire companies couldn't accomplish through conventional means. This lesson influenced post-war American military thinking, contributing to the development of specialized weapons and tactics for specific tactical problems rather than relying solely on mass and firepower. The engineers and soldiers who developed flamethrower tactics in combat pioneered what would later be called combined arms integration at the small unit level. A flamethrower team wasn't just an operator with a weapon. It was a coordinated unit combining suppressive fire, movement, specialized weapons, and infantry support, all working together to achieve an objective. This model influenced everything from Vietnam-era tunnel-clearing operations to modern urban warfare tactics. The flame weapon's effectiveness also sparked debate about the ethics of warfare that continues to this day. International agreements, including the 1980 Convention on Certain Conventional Weapons, would eventually restrict the use of incendiary weapons against civilians and in civilian areas, though not prohibit them entirely in military operations. The World War II flamethrower operations provided much of the evidence and testimony that shaped these later agreements. The moral complexity of the weapon was recognized even during the war. Chaplains serving with units equipped with flamethrowers reported that operators sought religious counseling at higher rates than other combat soldiers. The nature of the weapon, its intimacy, its cruelty, its effectiveness, created moral burdens that conventional weapons did not. One chaplain, Father Michael O'Brien, who served with the 1st Infantry Division, wrote in his war diary in March 1945, "Today I spoke with a young man, barely 21, who operates a flamethrower. He has burned German soldiers alive in bunkers across France and Germany. He knows this was necessary, that these fortifications would have killed many of his comrades. He understands intellectually that he did his duty and did it well, but he cannot reconcile what he knows with what he feels. He asks me if God can forgive him for the things he's done. I tell him yes, that God understands the necessities of war. But I wonder if he believes me. I wonder if I believe myself. The weapons we have created force good men to do terrible things. That is perhaps the greatest sin of all. The industrial production system that supplied flamethrowers to the European theatre represented American manufacturing capability at its peak. The weapons required precision manufacturing, pressure vessels, regulators, ignition systems, all had to meet exact specifications to function reliably and safely. Yet production scaled from essentially zero in 1942 to thousands of units annually by 1944. The fuel production was equally impressive. The thickening agents required for effective napalm were complex chemical compounds that had to be manufactured, mixed with gasoline in precise ratios, and packaged for transport. The supply chain extended from chemical plants in the United States, across the Atlantic through U-boat-infested waters, through supply depots in England and France, finally reaching combat engineers at the front lines. That this system worked reliably enough to keep hundreds of flamethrower operators supplied with fuel represented a logistical achievement comparable to any other aspect of the war effort. Each gallon of thickened fuel required approximately 2 ounces of aluminum soap thickener, which itself required processing of bauxite ore, chemical treatment to create aluminum salts, and combination with specific fatty acids to create the final thickening compound. The entire process, from mining raw materials to delivering finished fuel to the front, involved thousands of workers and dozens of facilities. German attempts to replicate American napalm-based flamethrower fuel failed, not due to lack of understanding of the chemistry. Captured American equipment provided complete details, but due to lack of resources. Germany by 1945 lacked the aluminum, the chemical processing capacity, and the gasoline to produce effective flame fuel in meaningful quantities. Even knowing exactly how to make the weapon, they couldn't manufacture it at scale. This encapsulated the broader reality of the war. American industrial might, once fully mobilized, produced weapons in quantities and qualities that Germany simply couldn't match. The human cost of flamethrower operations extended beyond immediate casualties. Among American operators, the casualty rate of 40% meant that nearly half of all men trained to use the weapon were killed or wounded. Among German defenders in positions attacked by flame weapons, the casualty rate approached 90%. Those who weren't killed were often horribly burned, suffering injuries that would cause pain and disability for the rest of their lives. The medical treatment of burn victims from flamethrower attacks strained military medical resources. Severe burns covering large portions of the body were difficult to treat with 1940s medical technology. Many victims died days or weeks after the initial injury from infection or shock. Those who survived often required months of hospitalization and multiple surgeries. The psychological trauma of burn injuries compounded the physical damage. Soldiers disfigured by burns struggled with depression, social isolation, and post-traumatic stress long after physical wounds healed. American military hospitals in the European theatre developed specialized burn treatment centers specifically to handle casualties from flame weapons, both friendly forces injured in accidents and enemy soldiers captured after attacks. These facilities pioneered techniques in burn treatment that would influence civilian medicine for decades. The use of saline baths to prevent infection, early excision of burn tissue, and skin grafting procedures were all refined through treatment of combat burn casualties. One unexpected consequence of flamethrower deployment was its impact on German surrender rates overall, not just for positions directly threatened with flame. Word spread through German units that Americans gave an opportunity to surrender before using flame weapons. This created an incentive to surrender early when faced with any overwhelming situation, before weapons like flamethrowers were brought forward. American intelligence officers noted that after flamethrowers became widely known in late 1944, German units began surrendering earlier in engagements, often citing fear of flame weapons even when none were present. The weapon's reputation created a psychological pressure that extended across entire sectors of the front. German soldiers knew that continued resistance might eventually bring flame weapons into play, making surrender increasingly attractive as battles progressed. This psychological dynamic saved American lives by reducing the intensity and duration of combat. Battles that might have dragged on for days as Germans fought from prepared positions, instead concluded in hours as defenders, fearing flame attack, chose surrender over prolonged resistance. The statistical analysis bore this out. Sectors where flamethrowers were known to be available saw 35% shorter battle durations and 40% higher enemy surrender rates compared to sectors without flame weapons, even controlling for other factors. The impact of American flamethrowers on German tactics extended to their engineering practices. Captured German engineering manuals from 1945 showed fundamental changes in bunker design principles. Earlier manuals emphasized thick concrete walls, narrow firing slits, and central ammunition storage for ease of access. Later manuals, written after extensive experience with flame attacks, emphasized multiple separate chambers to prevent fire spread, external ammunition storage to prevent cooking off, and complex ventilation systems designed to expel flame and toxic gases. These design changes, while theoretically sound, were largely irrelevant by the time they were implemented. Germany lacked the concrete, steel, labour and time to construct new fortifications to revise specifications. Existing fortifications couldn't be meaningfully modified. The new manuals represented acknowledgement of the problem rather than a solution. More tellingly, the later German engineering manuals included extensive sections on camouflage and concealment of fortifications, recommending that bunkers be hidden rather than made resistant to attack. The implicit admission was that if Americans found a fortification, they could destroy it with flame regardless of how well it was built. Better to hide and hope to avoid detection than to build strong positions that would simply become crematoriums. The American flamethrower also influenced Japanese defensive tactics in the Pacific Theater, though that story parallels rather than intersects with the European experience. Japanese forces, facing similar flame weapons, developed similar fears and similar futile countermeasures. The psychological universality of fire as a terror weapon transcended cultural and geographic boundaries. Humans everywhere fear burning alive. This made the flamethrower uniquely effective across all theatres and against all enemies. In the final weeks of the European war, as German forces collapsed, American flamethrower operators found their missions changing. Rather than conducting assaults on defended positions, they increasingly performed demonstrations to encourage surrender. An operator would burn an abandoned vehicle or building within sight of German positions, showing what would happen if resistance continued. Often, this was sufficient to trigger immediate surrender. The weapon had evolved from a tactical tool to a psychological instrument of coercion. The transition highlighted an important truth about the flamethrower's effectiveness. Its power derived not primarily from its destructive capability, considerable though that was, but from its psychological impact. The fear it generated accomplished more than the fire itself. By war's end, the reputation of the weapon was so fearsome that often it didn't need to be used. Its mere presence, or even the rumour of its presence, was sufficient to break enemy resistance. This represented a complete victory in the realm of psychological warfare. When the European War ended on May 8, 1945, American forces had employed flamethrowers in hundreds of engagements across France, Belgium, Holland, and Germany. The weapon had proven instrumental in breaking the Siegfried Line, crossing the Rhine, and reducing the Ruhr Pocket. Military analysts estimated that flamethrowers had saved tens of thousands of American casualties by shortening battles and encouraging surrenders. The cost had been measured in the thousands of German soldiers who died by fire, and the hundreds of American operators who were killed or traumatized by carrying the most feared weapon on the battlefield. The American flamethrower in Europe stands as perhaps the clearest example of psychological warfare's power in modern combat. It defeated not through superior firepower, though it was devastating, but through terror. It bypassed fortifications not by destroying them, but by making them uninhabitable. It broke enemy resistance not through attrition, but through the fundamental human inability to willingly face burning alive. In doing so, it revealed uncomfortable truths about warfare and human nature. That fear can be as effective as destruction, that psychological weapons can achieve strategic effects, that the most humane weapon, measured by lives saved, can also be the most cruel in its application. These paradoxes ensured that the flamethrower would remain controversial long after the war ended. Veterans carried the memories of what they had done and witnessed for the rest of their lives. The screams of burning men echoed in their nightmares decades later. Some made peace with their actions, understanding them as necessary in the context of total war. Others struggled with guilt and moral doubt that no amount of rationalization could fully resolve. The weapon had done its job perhaps too well. The flamethrower had turned concrete bunkers into crematoriums, had made the strongest fortifications into death traps, and had broken the will of German forces to continue fighting from prepared positions. In doing so, it had shortened the war and saved lives on both sides. But the manner of those savings, the burning and the screaming and the terror, left scars on those who employed the weapon that would never fully heal. The legacy of the World War II flamethrower extended far beyond 1945. The tactical lessons learned influenced military doctrine for generations. The psychological insights shaped thinking about deterrence and coercion. The moral questions raised contributed to international agreements restricting incendiary weapons. And the memories carried by veterans, both those who used the weapon and those who faced it, served as terrible testimony to war's capacity to force good men to do horrifying things in service of necessary objectives. The American flamethrower succeeded completely in its tactical mission, while failing utterly to provide clean conscience to those who wielded it. That contradiction captures the essential tragedy of the weapon, and perhaps of war itself.